So we're on page 3 of the geometry formulas, and when we draw one diagonal into a rectangle, we wind up with this right triangle, and we can use the Pythagorean theorem. You may recall the name of this part of the triangle. It starts with an H. It's the hypotenuse. So we have two legs of a right triangle. This symbol means we have a 90-degree angle here, and the side across from the right angle is a hypotenuse. And if you've heard a squared plus b squared equals c squared, that is another way that people write this formula. C is the hypotenuse. A and B are the two legs. So we always say this squared plus this squared equals this squared. I wrote it out with the letters in the rectangle. So we're using d squared equals L squared plus W squared. I wanted to keep it in this building context. So if we draw a rectangle and label it 12 by 16, then we can draw one diagonal in there, and we can try to work out the length of the diagonal. So if this is 12 and this is 16, how long will the hypotenuse be, or the diagonal? And then if we're squared up, this diagonal will be the same length. So pause and try 8 and 9 and see how far you can get. So here's my 12 by 16 rectangle with one diagonal, and I put the 12 feet here, but I also labeled 12 feet here. And we're trying to find the length of this diagonal here, so I wrote d squared equals 16 squared plus 12 squared. And recall that this means 16 times 16, so we get 256, and 12 times 12 is 144. Add those together and we see that d squared is equal to 400. So you may already know what d is, but let's just go on a little sidetrack to review squares and square roots. D squared equals 16 means that d times d is 16, so d would have to be 4. And we express this relationship by saying that d is the square root of 16. So we're going backwards. We're unsquaring the 16 and going back to 4. If d squared is 100, do you know what d is? D is the square root of 100. So d is going to be 10. Now, what times what is 500? That's a little trickier. I can't do that one in my head. Some of these come out nice. 100 is a perfect square, so the square root comes out nice and clean. 500 comes out kind of messy. So I'm going to hop over to a calculator to find the square root of 500. So I've got my Desmos scientific calculator pulled up. If you've got a scientific calculator in your hand, often it's a toss-up whether you push the square root and then the 500, or do you push the 500 and then the square root button. So play with your calculator to see what it wants you to do. The correct answer should be 22.36. So just to check that result, I'm going to see 22.36 times 22.36, and that sure enough gets me basically 500 back. The only reason it's not is because I lost a few decimals there. So the correct answer here is 22.36. And it's okay to just keep 2 decimal places here. D squared is equal to 80, so what is d? Okay, pop over here, square root of 80. Square root of 80. 8.94. So I'll try 8.94, and if I want to square it, I can just press the squared key, And that basically gets me 80, pretty close, 79.9. So 8.94 is what I'll type in here. And again, it's okay if we're approximating. 200, that's another one that won't come out very nice. So square root of 200 is 14.14. And finally, the square root of 400, which is the question that we had. What times what is 400? It's actually just 20. That's a nice perfect square again as well. So when we look over here, 100 is a perfect square, 400 is a perfect square, 16 is a perfect square. So sometimes you take square roots and they come out nice and clean. Just make sure you know how to do a square root in your calculator. Finish finding the length of the diagonal in the 12 by 16 foot rectangle. Well, I think we got it. Because we had d squared equals 400, so that means 20 feet is the diagonal of that rectangle. And that made it pretty easy for me to check my diagonals on that 12 by 16 shed that I was building, because it's exactly 20 feet. So here's a skewed 12 by 16 rectangle, and here's one where the diagonals are equal. So you can practice that same process with a 10 by 20 foot rectangle. Draw the rectangle, draw a diagonal, use the Pythagorean theorem to find the length of the diagonal. You can pause this video, work it out, and then see how you did. So this comes out to be 20 squared plus 10 squared, 400 plus 100 is 500, take the square root. There's that 22.36 that we got earlier, so that's the diagonal. Now there is one thing that's a little tricky because I don't have 0.36 on my tape measure. I know it's bigger than 22, and I know it's not 22.5 feet, but what is 0.36 feet? I need it to be in inches. So this next question, I show you how to convert that to feet and inches. You take 0.36 times 12. And it doesn't even come out clean that time. It's 4.32 inches. So you now know that you're over 4 inches. So 22 feet and a little over 4 inches. And this is actually about 5/16 of an inch. If you want to take this to the next level, you multiply 0.32 times 16, and when I do that, I get 5.12. So it's approximately 5/16 of an inch. And that's a little weird probably for you, but I've used this skill plenty of times when I'm doing carpentry and I need to convert a decimal into inches and fractions of an inch. I think you can see though that this is less than 4.5 inches and it's a little over 1/4 of an inch. So this is the most accurate. 4 1/4 would probably do for checking your diagonals on this. It's certainly not as nice as the previous shed where we got exactly 20 feet for the diagonal. So here's a little review for you on area and circumference of a circle. I would recommend writing down everything you know. It might be review. And then we're going to work out finding the area and circumference of a circle with a 5-inch radius. Here it is. If the radius is 5 inches, the diameter is 10 inches, and often people refer to circles by their diameter, but the formulas are given in terms of the radius, pi times radius squared. Circumference is 2 times pi times r. And we should probably remind you that pi, if I don't have a symbol, I just type pi, is approximately 3.141592 forever. And 3.14 usually works fine. It's not what mathematicians want you to do, but it might be close enough in most real-life situations. So there is a pi button on your calculator, so let's talk about how to do that. If you're finding the area and you're doing pi times 5 squared, only the 5 gets squared. That's that exponent's first multiply second. So in the Desmos calculator, I don't have pi until I click function, and then I go to pi, back to main, times 5, and then the squared key. And there's my 78.54 square inches. Let's see if I can make this a little bigger. Okay. So that gave me the area of the circle. If I just did 3.14, oops. If I did 3.14 instead of pi, changes my accuracy slightly, but it's still pretty close to the same answer. If we look at the circumference of the circle, the distance around the circle, 2 times pi times the radius. So 2 times pi button times 5 gives me 31. It's basically just 10 times as big as pi. So we can round it to 31.42 inches. And I decided to do this in inches because I was actually thinking about pizza. And it seems like 10 inches might be the size of a pizza. When we label this answer, we say inches because it's a distance. When we label this answer, we say square inches because you're finding out how much space is enclosed by the circle. So I'm just emphasizing that here.